Standard 6.4, graphing exponential growth and decay functions. All right, so let's begin with our parent graph. This is our most basic graph, and then from here we're going to have either translations, reflections, etc. The equation for our parent graph looks like the following. It's in the form y equals a b to the x. And, excuse me, b is what we call our growth or decay factor. And when our value of b is greater than 1, our function is a growth function. And when b is between 0 and 1, our function is decay. If you have, let me go back a moment. So if we were to graph this function, it looks like the following. It has a horizontal asymptote here along the x-axis at y equals 0. And it takes on the following shape. This blue one is growth. It's increasing. This green one is decay. Now, if we have a vertical translation, so if there was a plus d other than 0, of course, that would move our graph up or down, and that would include pushing our asymptote in the upwards or downwards direction. If you had a negative in front, that would flip your function, or the graph of your function. So a decay would be flipped and look like this. That's if you had a negative on front. If you flipped a growth, it would look like that. All right, so keeping these things in mind, let's take a look at our function here. We're going to graph the following function, and we want to decide if it's growth, if it's decay. We want to find the asymptote. We want to include at least 2 points, even more if we need to. All right, so if we look on the end here, this is in the form y equals, this is a, this is b, this is our plus d. And this d indicates a vertical translation. We are graphing 1 unit up from our parent graph. So our horizontal asymptote is now at 1 instead of at 0. The equation for our horizontal asymptote is y equals 1. Notice that b is greater than 1, which means that it's going to be growth. Don't just look at it as a fraction and say, oh, it's decay, right? We want to see the value of the fraction. It's greater than 1, it's going to be growth. There is no negative sign in front of our a, so it's going to be our regular growth function. It's going to lie above our asymptote here. Okay. So now let's pick some points. We can just create even a mini xy table here. And I'm going to pick maybe, let's start with 2 points, and then we'll go from there. So let's say that I pick x to be equal to 0. So let's plug 0 into our function. 2 times 4/3 to the 0 minus 1 plus 1. You can use your calculator if you want. This is 4/3 to the negative 1 power. This negative flips it to 3/4. 2 times 3/4 is basically 1 1/2. 1 1/2 plus 1 is 2 1/2. So when we put 0 in, we get 2 1/2 back out. Let's plot that point. 0, 2 1/2, so right around there. All right, let's put the x value of 1 into our function. So we'll do that work here. 2 times 4/3 to the 1 minus 1 power plus 1. This is 4/3 to the 0, which is 1. This works out to be 3. So 1, 3 is another point on our graph. So here's 1, here's 3. Now, knowing that it's growth, we have an idea of what our graph looks like, and so we can just connect the points that we have and incorporate the shape that we already know it's going to be. If you wanted to, you could include some more values on your XY table to get a more accurate graph. All right, let's look at our next example here. Notice in this particular example, our b value is less than 1, so it's decay. This minus 2 is going to shift our graph down 2. And this negative indicates that it's going to be a reflection of our decay graph. So our graph's going to lie below our asymptote. So right now our asymptote is at -2. y equals -2. And let's put some points in our xy table to get our graph. So let's suppose we pick 0, and let's just pick 1. So if we pick 0, -5 times 1/3 to the 0 minus 2 is -5 times 1 minus 2, so -7. 0, -7 is a point on the graph. 1, 2, 3, 4, 5, 6, 7, which makes sense. All of our points should lie below our asymptote because of the negative. All right, now let's pick 1. If we put 1 in, we have -5 times 1/3 to the 1 minus 2. So that's -5/3 minus 2, -5/3 minus 6/3. That's -11/3, which is equal to -3 2/3. So almost -4. So at 1, we have -3 2/3, almost -4. There's our graph. Now, keeping in mind that our decay graph looks something like this, and we have a negative, it's going to be a reflection of. So our graph is going to actually look something like that. Make sure your graph does not cross your asymptote, that the entire graph lies below the horizontal asymptote in this particular case. This is standard 6.4, graphing exponential growth and decay functions.